Hey everyone, thanks for coming out and welcome to our talk on DDoS response in the cloud. We got a lot of content for you. I'm really excited to get started. This is an advanced level topic on not only DDoS mitigation and preparing your architecture to mitigate attacks, but also those things that are most interesting to engineers as you think about not only building applications, but monitoring them for signs of DDoS attack, monitoring those applications for signs of application impact, and then responding to attacks. What do you do after you find the DDoS attack? How do you get in touch with the DDoS expert? So that's really what we'll be covering in this talk today. If you're interested in a more fundamental approach or a basic conversation about DDoS mitigation, we also have another presenter who'll be coming up right after this one, after this talk. So my name is Jeff Lyon. I'm a development manager with AWS Perimeter Protection, and we're the team who's responsible for the AWS DDoS response team. I'm also joined by Yazid Bouchizdir, who is an AWS Solutions Architect, and Eric Neustetter, who is the Vice President of Technology with the POKÉMON Company International. So on AWS, we think about DDoS mitigation sort of in three pillars, and those three pillars are to prepare your architecture, make sure you're using a best practices architecture that is able to mitigate the attack, monitor the application, make sure that you know when you're under attack and you know what the signs of impact are, and you know whether an attack is actually causing problems for your users. And then knowing what to do, how to respond. And if you're subscribed to AWS Shield Advanced, which I'll get into in a moment here, how do you engage with the AWS DDoS response team? So there's a lot of different types of threats that you may be thinking about or may be concerned with as you think about security on the perimeter. And they tend to fall into three major categories. And those are DDoS attacks, application attacks, and bad bots. And the one thing that you might find interesting about these three classes of attack is that all of them, with the exception of DDoS, are at the application layer. This means that you, by yourself, without having to buy any additional services for DDoS mitigation, can actually take advantage of services that we offer on AWS to mitigate these threats yourself. But with DDoS attacks in particular, it's a little bit different. You have the ability, using tooling we provide, to mitigate HTTP floods, but you actually rely on AWS to protect you against those network and transport layer attacks. And these are the types of attacks that you may have had to traditionally mitigate yourself when you were on premise, but now expect to be handled for you because you've moved your application to the cloud. And so there's a lot of different threat vectors, and you see some of them are mentioned up here. But I think the key takeaway is that these are really just the three major categories to think about, and that the services we'll talk about in today's presentation will give you a comprehensive defense against all of these vectors listed. So I want to take an opportunity to talk about what I call the evolution of DDoS mitigation. So at first, many years ago, your applications were probably running on-premise. You had your own data centers. You might have had your own DDoS mitigation systems. You had to buy your own capacity and think about how to manage these things for yourself. Then there was cloud routing. Cloud routed was this idea that you can buy a third-party service, send your traffic off somewhere else, and ask that third-party service to mitigate the attack on your behalf. And today on AWS, you get to take advantage of what we call cloud native, meaning that the DDoS mitigation to protect your application against impact is built fully into the AWS global infrastructure. So on premises, you had to do everything yourself, but there were actually some benefits with this. You had full visibility and control into everything on your network. You could buy the appliances you wanted to buy to mitigate the DDoS attack. You could buy the capacity you wanted to buy. You could decide how much capacity to buy. But the challenges with this is that it incurred large capital expenditures, maintenance costs, and you had to maintain your own in-house expertise. I mean, you had to hire people who knew about DDoS attacks and other application threats and make sure they were prepared to respond. But with cloud routed, so some years ago, different companies started offering this idea that you can route your traffic somewhere else to have it scrubbed for you. And you could do that through BGP GRE tunnels. You could do that through WAFs that operate as a proxy on somebody else's network. And really the benefit here is that a lot of the heavy lifting was abstracted, and you didn't have to maintain your own capacity for attack mitigation. But the challenge is that it's a black box. So you engage with one of these companies, they tell you, trust us, it works, you just send us your traffic, we send it back to you clean. And for the most part, that's true, but you don't have full confidence as an end user or as a customer that this is actually working the way you expect it to work. And then there's some other challenges that come into play. It can introduce additional latency because you're sending that traffic to another network. It can introduce additional points of failure. So if a third-party network fails between you and the mitigation provider, then that can also impact your application. And there could be increased operating costs, because a lot of these services were not always the cheapest services available. But today on AWS, we give you Cloud Native. And Cloud Native is, no matter how your traffic ingresses AWS, at any point on our global infrastructure, we'll mitigate it right there without sending it to a third-party network. We accomplished this with 16 regions, now 107 edge locations. And we've been adding those edge locations at a pretty rapid pace. So that actually gives you the ability to take advantage of capacity not only in the region where you're operating, but using services like CloudFront and Route 53, it gives you the ability to tap into all of that capacity we have across the world. And this gives you all of the different capabilities that you require for attack mitigation without undifferentiated heavy lifting. Or another way of saying that is without doing things that don't add value for your business. So if you're not an infrastructure company, there's no reason that you should have to think about these things or manage them. So for DDoS mitigation, we offer you two different tiers of protection. We offer standard protection and advanced protection. And the benefit with this is everyone in the room here who has workloads on AWS already right now has full DDoS protection using our standard product. It's available to everybody. You don't have to sign up for it. And there's no additional cost for what you already pay on the cloud. And then we offer advanced protection. So advanced protection provides you with new capabilities in addition to just attack mitigation. So with standard protection, you're automatically protected against the most common attacks in any AWS region, no matter where you operate. However, if you place CloudFront and Route 53 in front of your application for application delivery and DNS service, then you actually gain comprehensive defense against all known network and transport layer attacks. And then additionally, you receive application layer defense using the AWS WAF, or Web Application Firewall service. So with advanced protection, you get some additional benefits. And some of the key benefits include fast escalation to the AWS DDoS response team. So if you're having an impact on your application or you have some concern with the DDoS attack, you're able to quickly get in touch with a team of experts, the same team of experts who's responsible for protecting AWS infrastructure and the Amazon.com websites against DDoS attacks. So you gain access to that capability by subscribing to this optional service. You also gain attack visibility and enhanced detection. So this means that when there's a DDoS attack, you'll see it right there in your console. You'll be able to consume that by the API, and you'll also have access to see this in Amazon CloudWatch. And then enhanced detection gives you finer granularity, the ability to see DDoS attacks that are smaller than what we would ordinarily detect using our standard protection service. And then you receive cost protection. And this is a pretty big deal because a lot of our customers have told us that we're concerned about elevated costs when there's bursts of traffic that you didn't expect from real users. So for example, a DDoS botnet comes in and it causes scaling of things like Amazon EC2, your load balancers, CloudFront request fees, Route 53 DNS queries. And so when you're using AWS Shield Advanced, with the cost protection, you can actually request a credit of those costs so that you don't see your cloud bill elevate just because you had to scale or use our services to mitigate the attack. Then lastly, you receive the AWS WAF at no additional cost. So you only pay for Shield Advanced, and then all of your utilization of the AWS WAF service, you don't have to pay for that. So I'd like to tell you a little bit about how all this works under the hood. And so I'll tell you about our defense in depth. So we mitigate attacks at multiple different layers throughout our network and across our services. The first thing we do is internet layer mitigations on our border network. So this is the ability to communicate via API or BGP community with our carriers and peers and tell them how they should be handling traffic on the network. What should they do with the traffic? How should it ingress AWS? Should it be blocked? Should it not be blocked? And then we also offer network layer mitigations. And network layer mitigations take advantage of a DDoS mitigation system that we've built called CloudWatch. And CloudWatch is our proprietary solution, and it provides us with not only DDoS mitigation at the network border, but a tight level of integration with AWS services. So there's a communication between the CloudWatch system and the AWS services, and that CloudWatch system has context on what the AWS service is and what kind of traffic it's able to handle, and also the composition and type of traffic that should be destined for that service. And a couple of the benefits here for you as a customer is that it provides us with an order of magnitude larger capacity at an order of magnitude lower cost. So this means that at any one of our edge locations, we have enough DDoS scrubbing capacity on these systems to mitigate the largest DDoS attacks that we have seen, and also to provide you with this capability without having to increase your costs of operating on AWS. And when our costs of operations go down, that enables us to do things like consider price drops for services like WAF, like Shield, and other AWS services. Also, there is built-in protection into the AWS services themselves. So even without DDoS mitigation on the border, without this ability to communicate with our carriers, every AWS service is built for resiliency. It's built to be able to handle floods of traffic and to be able to block that traffic, drop the traffic that is not intended for real applications running on AWS, keep your application online, continue to serve your end users. I mentioned that we have the AWS WAF, and this is how you mitigate web layer attacks. It gives you the ability to mitigate things like HTTP floods, bad bots, and suspicious IP addresses. So if there's any kind of traffic that you don't want to see towards your application, use the AWS WAF, build a rule, block that traffic. And then lastly, for customers specifically who are subscribed to AWS Shield Advanced, you can reach the DDoS response team, and you don't even have to manage the WAF yourself for a DDoS attack. You can actually just reach out to us, let us know that you're in pain, and then we'll figure out what rule needs to be created in order to restore the performance or availability of your services. So the first pillar that I mentioned was preparing the architecture, and you may have seen this a lot in our documentation and white papers. The first step is to have an architecture that uses services that best take advantage of the DDoS mitigation capabilities that we have built. So what I have here up on the screen is a pretty common architecture on AWS. It takes advantage of VPC, where you can build network access control lists, configure security groups. It takes advantage of private and public subnets so that attackers or even end users can't access the instances directly. They have to go through the load balancer. And it takes advantage of the application load balancer, which is a service that distributes traffic towards your EC2 instances and only allows legitimate HTTP traffic to pass. And then if there is a flood of traffic, be it from a flash crowd or a DDoS attack, that application load balancer will transparently scale up and absorb the excess traffic. But we want to give you the best overall architecture. What can you do to take advantage of all of our capabilities across the global infrastructure and have the best overall defense? So I give you some additional services here that all operate from our edge network. And these are Amazon CloudFront for application delivery, AWS WAF for blocking application layer attacks, Route 53 for serving your DNS, and also the Amazon API Gateway, which takes advantage of CloudFront for request termination. So when there is a DDoS attack, here's some of the key capabilities that you can expect. With CloudFront, you get a globally distributed attack mitigation capability. You get a SYN proxy that verifies the three-way handshake before passing a connection onto the application to make sure that it's legitimate before the CloudFront service tries to process it. And lastly, you get a slow loss mitigation that reaps long-lived connections. So if a connection's open for too long, and we believe that it's potentially a DDoS bot, we're going to close down that connection. But we're going to do this in such a way that it first closes down the ones that are most likely to be DDoS bots and holds open those good, valid connections. With the AWS WAF, you get a flexible rule language, or what I sort of like to call an object-oriented WAF, which allows you to create rules, apply those rules to any number of CloudFront distributions or application load balancers, and to reuse those rules very easily. So as you scale your application and add more components and add more services, you can keep taking those same rules and applying them all to what we call a web ACL. And so every rule that's in a web ACL, will actually be enforced against every resource that is associated to that web ACL. So it makes managing WAF at scale very easy for you. You get Amazon Route 53, which validates first that the DNS header is legitimate, and it mitigates complex attacks by allowing only the most reliable queries. And so when we say reliable queries, think about all of the DNS queries that you expect to come into a DNS service. You expect them to come from your real users, from resolvers that we expect to see at volumes of traffic that are normal for DNS, and we expect them to have header compositions that make sense. And this is just a few of the many attributes that we use to evaluate that traffic. So the traffic that looks to be most like a DDoS attack gets a low priority. The traffic that looks to be most like a human user is going to get the highest priority. And when we find it necessary to start shutting off that traffic, it's that low priority, highly likely DDoS or botnet traffic that is going to get dropped. Your real users that are making DNS requests will continue to be served. So with that, I'll actually go over to our demonstration. All right, and so I'm ready to get started. So let's go ahead and show you what we have to offer in the AWS console with regard to DDoS mitigation and application security. So I'll start out by showing you the AWS WAF and AWS Shield console. So on the left-hand side of the screen here, you see that you have the ability to create match conditions that go into AWS WAF rules. You have the ability to create rules, and then you also have the ability to build web ACLs that contain your rules and have resource associations. And so that's available to you even if you decide you don't want to purchase AWS Shield Advanced. You're able to use with CloudFront and ALB the AWS WAF product to defend against application layer attacks. And that includes all kinds of different application layer attacks, not just DDoS. And I want to show you something else that we just launched yesterday that you might find really interesting. And this is the managed rules for AWS WAF. And so we provide you with a marketplace where you don't actually have to create your own rules. If you want to have a WAF that is fully managed for you, you have the ability to come in here, select a security vendor that you choose to work with, decide which rule or type of rule makes the most sense for your application, subscribe to that rule set, and then associate it to your web ACL. So it makes using web application firewalls at scale in the cloud really simple, even if you don't have the expertise within your company to be able to manage these things for yourself. But I want to jump over to AWS Shield and show you how all of that works. So this account is already subscribed to AWS Shield, so I don't have to do anything. If you weren't subscribed, you'd be given the option to sign up, agree to some pricing terms, and then everything would be good to go within a few seconds. And you see that I already have some resources that are protected with AWS Shield. And I'm just going to add another one to show you how easy it is. I'm going to add a CloudFront distribution. And I'm going to take that CloudFront distribution and I'm going to associate it with one of the AWS WAF web ACLs. And this is something that gives you application layer attack visibility. So if there's a layer 7 DDoS flood, we're able to detect that additionally with the AWS Shield Advanced service. Network layer DDoS attack mitigation is already enabled, so I'm just going to click Add Protection to Resource. And you see that that happened automatically. And so when there is a DDoS attack, you have the ability to see the incidents right here in the console. I'll go back to that in a moment when I do my attack demo. But I also wanted to show you this, and this is the global threat environment. And the global threat environment is something we just launched this month, which gives you the ability to see not only the DDoS attacks that we've detected against your resources, but every DDoS attack that we have seen across Amazon summarized into the console. And the reason this is really useful is maybe you want to validate some things that you saw in the media or you saw a threat report, and you want to see, is Amazon seeing that same kind of traffic? Or you just want to try to get a sense of how is the global threat environment, how is it relative to the attacks that you're seeing in your incidents panel? So that's the overview of these two services. They all operate from the same WAF and Shield console, and it's really quite intuitive to manage, add resources, create new rules. But what I would like to do is show you how I monitor for DDoS attacks. So with AWS WAF and separately with AWS Shield Advanced, you get CloudWatch metrics. And these CloudWatch metrics will tell you if we detected a DDoS attack, and they'll also tell you what is the volume of requests that are coming into your AWS WAF. And so you can use these two sets of signals to set up alarms and engage your operator if there's any sort of anomaly to which you need to respond. So I'd like to show you my DDoS monitoring dashboard that I built. And this shows you HTTP floods. You see I have no traffic on HTTP right now. And it shows you whether a DDoS attack was detected. And so what I want to do is I want to attack myself to show you what this looks like when an attack occurs. I have the Jeff Lyon cat blog. And the Jeff Lyon cat blog, it's a really bad blog. The content's pretty poor. And the other reason that it's bad is that I've done nothing to optimize this. I'm not caching anything in CloudFront. I've not done any optimization in my instance. It's a very small instance. So when I attack this thing, it's going to fall over. And I need a way to be able to detect that and respond. Ideally, with your applications, you have very resilient architectures. But for the purpose of the demo, I just didn't want to have to spin up too many instances to flood myself. Keep that quite simple. So let's flip back to CloudWatch here. I'm going to go off screen and actually launch the attack. Then you'll get an opportunity to see how this all works. Okay, so now I have an attack underway. It's a multi-vector attack. So I'm doing both a UDP flood against my instance, and I'm also doing an HTTP flood. And you can see the HTTP flood. I have the server top open right now, and there are a ton of requests coming in. It's driving up the load average on this server. So this server is not going to do very well if a real user is trying to access it. So I'll come over here, and I'll try to reload my blog. And it's not reloading, so we need to do something about that. So let's go over here to CloudWatch and see what we have. So it says a DDoS attack's been detected, and I see the first data point starting to come up in the HTTP flood alarm that I've set up. So in just a moment, I actually expect my pager to go off with this alarm. So CloudWatch just has to catch up. There we go, the attack's detected. You see that's in state of alarm. I want to show you briefly the way that I did this. I've actually integrated the CloudWatch alarm with a service called PagerDuty. And PagerDuty is just one of many AWS partners who offer services that integrate with CloudWatch and allow you to receive notification when there's an attack or other change in your application. So there's the attack. I see that it's in PagerDuty. So I want to go ahead and resolve that alarm. So I'm going to go ahead and resolve it. The way I set this up was really quite simple. I used an SNS topic, and I took the endpoint that PagerDuty provided to me and just subscribed that endpoint to the SNS topic, and you can see that right up here. The other thing that's really cool that I wanted to show you on PagerDuty is that there's a extension capability, and the extension capability allows you to also send the alarm into another application. So you see that Slack is one of the options here, and just for demonstration purposes, I have also integrated with Slack. So you see that the alarm popped up in PagerDuty there. So now I know that the attack has occurred. I want to actually mitigate it. So I'm going to go back to my WAF. And I'm going to show you the rate-based rule that I set up. And the reason that it didn't automatically mitigate is the rate-based rule that I have. Let me go over to the CloudFront. So go over to global. So I have this rate-limiting rule that allows only 2,000 requests in a 5-minute period from a single IP address. And so when that's exceeded, the IP address will temporarily go into this blacklist heap. There's the other alarm. And you can see all of these IP addresses were identified as being bots, but they're not being blocked right now. So I need to take care of that. I'm going to go over to my web ACL. I'm going to click on Shield Demo, ACL, which is what I called it. Click on my rules. edit the webACL, and I'm just going to switch that to block mode. So now that rate limit rule is now beginning to block requests. So the next thing it's going to do is go in there and start blocking those IP addresses that were identified as being bad IPs. And then you can see here in the shield console that the UDP attack that I launched is also being detected. So you get a red numeral there next to incidents. You get this red box that says, okay, there's an attack with mitigation in progress. And then you also have the ability to click here on the affected resource and see a summary of the attack. So right now, I don't have any summary because this hasn't populated yet. That data's still being collected. But if you look back at an older attack, you can actually see that a graph will populate. And if it wasn't a demonstration, if this was a real attack in the wild, you would also see a bunch more information below this graph. So for a layer 3-4 attack, you would see things like the source IPs, the source geographies, and also the source AS numbers, or networks for which that traffic originated. And we have some similar attributes that we can give you if we detect an application layer attack using our entropy detection method. So let's take a look at the server again. And the load averages are actually dropping. So let's see if my application has recovered. There we go. And so the cat blog is now loading. So that's all I had for my monitoring demonstration. I would like to turn the stage over to Yazid, who's going to talk to us about engagement with AWS Shield Advanced.
Thank you, Jeff.
Thanks, Yazid.
Thank you. Hi, everyone. Thanks for coming and joining us at this session. So now that my colleague Jeff talked about how to build resilient applications in the cloud, I'd like to do a little deep dive on what are some of the things that you want to look for and some of the things you need to do immediately after DDoS takes place. So some of the things right off the bat you want to start looking at and considering are reviewing CloudWatch alarms, right? Or custom dashboard. Build some type of custom dashboard, port those CloudWatch metrics there so you can have them readily available to your team, NOC, SOC team. You can also, or you would also want to identify the level of the attack. So is this a hard down of application, or are we experiencing performance degradation?
Can you switch the KVM?
Oh, thank you. PC. Go. Thank you. So some of the things you want to look for, so you look at CloudWatch alarms, centralized in a centralized fashion. You want to look for or isolate or identify the magnitude of the DDoS. Is it a hard application down, or are we experiencing performance degradation? Other things you want to look for is things such as smoke screens, right? Sometimes attackers will create some shiny object during the DOS attack, so you can, your team gets preoccupied with the smoke screen while a real attack is happening elsewhere. And lastly, you get in touch with our AWS DDoS response team. Now, before you get in touch with DDoS response team, there are some key metrics that you would want to look at or measure. So to start, if we look at the architecture as a whole, we start at the very edge of the architecture. So if you look at AWS WAF, for example, you want to look at allowed request counts. You also want to look at blocked requests. You want to look at counted requests. Once we have an idea of what those requests are, we're going to move on to a little bit inside into the stack. So we look at DDoS metrics such as those that my colleague Jeff showed. And those are basically, you have two there. So you have the DDoS detected, yes or no, and then you want to look at the bits per second. So these are the key metrics you want to start looking at. And as we move inside, further inside the stack, we want to look at CloudFront. So CloudFront, and I'll talk about this in upcoming slides a little bit in depth, is a service that's available to you where regardless of where your application lives, it can be in AWS or outside of AWS, you can leverage CloudFront to protect it. It's a perimeter protection that's available to you. So when you look at CloudFront, for instance, you want to look at request counts and error rates. I'll catch up with you guys there. Route 53 is our DNS service. You want to look for health check status, right? Are we seeing errors there? And lastly, you want to look at your classic load balancer. So now, as you can see, I started from the WAF, and I'm working inside of my application stack. So once I get to my application classic load balancer, I look at HTTP error rate. I also look at spillover counts, surge queue linked. Once you see those metrics going up, there is a sign there that perhaps there's a DOS attack. Now, just to be clear, these metrics may or may not indicate, or for sure say, this is definitely a DOS, but these are metrics that help you further investigate. So once we look at those metrics in the classic load balancer, we start moving inside the stack further to an application load balancer. And again, in the application load balancer, we want to look for consumed LCUs. We look at, again, HTTP error rates. We look at request counts. If you're deploying a network load balancer, for example, you want to look also at LCUs. You want to look at net flow count. So these are metrics you want to look at proactively during an attack. And preferably, what we've seen some customers do is they have all these metrics gathered in a single dashboard, and it's always in front of their team. And that could be a NOC or a SOC team, and you are proactively monitoring. You're not waiting until a DDoS takes place. So once we do that, the last two pieces we're in the stack now is our compute, right? EC2 instance. And that one is relatively easy to monitor. You look at CPU, and you look at network in. So if a CPU spikes, that's another confirmation. And you look at network bandwidth coming in. And last but not least is your autoscale group. So your autoscale group goes to max size. Then at this point, you can say, OK, well, all of these metrics are showing a sign of a DDoS attack. Are we on the same slide there? Yeah, there you go. So once we look at all these metrics, now what? What do we do? Immediate actions. So there are certain things you can implement immediately, right away, before you contact anyone. So now that we've gathered this data, we know that there's a DOS attack and there are inside of our environment. There are certain things you can do immediately. So one thing you can do is the WAF rules. So implement WAF rules immediately. So today, if you're a Shield Standard customer, which if you're an AWS customer, you are, you can add on the WAF and you can configure the WAF rules. If you're a Shield Advanced, same thing. You can do the configuration yourself, or you can have our DDoS team help with that. And certain things you can do is block malicious pattern or block specific traffic, or look at anomalies in terms of source, IP addresses. And once we've done those preliminary mitigation techniques, there are a few other things you can add. CloudFront. So if you're a CloudFront customer today, you don't have to do anything. If you're not, you can actually deploy CloudFront on the fly, right? And we have a link at the bottom there, and feel free to take a picture, that actually helps you deploy CloudFront and WAF. A very, very detailed architectural diagram and steps on how to do it. The other option you have available to you is you can deploy CloudFront and put it on standby, and only launch it with a single click when an attack takes place. So you'll have some type of runbook for your SOC or NOC team or operations team, and they know when all these metrics have been met and we confirm it's a DOS attack, deploy CloudFront. So you have a few options there. The other thing I'd like to highlight with CloudFront is that it doesn't only work for static content, but it also works for dynamic content. So if you have dynamic content, CloudFront can help you too. So we talked about how to build a DDoS resilient application. We talked about what metrics to look for, what to look for specifically. And we also talked about what are some immediate actions to take. And now, let's say we've done everything. Now what? We're still under attack. It's still happening. And this is where you can engage with us, with our AWS DDoS response team. And there's a lot of different ways you can engage with our DDoS response team. So you can engage with our team via API. You create a case via API or console, or you can pick up the phone and call our support team. But when we talk to our customers, they mentioned to us or brought a concern to us and said, hey, how can you help us reduce the engagement time, right? We're under attack. There's a little bit of panic. Can we just get a hold of your DRT team immediately? So we thought about it as a team, and we came up collectively with customers with a few things that we can tweak to improve the process. So one of which was case generation time, right? Instead of going through API or console, can we automate that process and make it faster? The second one is a predefined and ambiguous messaging, right? During an attack, for anyone that works in or worked in a DDoS response team, or a SOC or a NOC, when an attack happens, customers calls you, there's a little bit of panic, and sometimes it takes a few back and forths or emails before the message is actually unified, or like, hey, this is what we need. So a predefined message helps avoid all of that confusion, and it's kind of ready. The second one is time to escalate. So instead of waiting for example, first level support to escalate to a second level, is there a way to parallelize the process, right? I want to inform the first level and second level in a single transaction. So the solution was to basically programmatically generate an AWS case and notify AWS DDoS response team at the same time. So with that, I'd like to introduce AWS Shield Engagement Lambda. So what is Shield Engagement Lambda? So Shield Engagement Lambda is a Lambda code that we've built that helps customers automate the entire process. So the way it works is as such. If you are a Shield standard customer, and if you're an AWS customer, you are, your operator, network or security operator, would use a trigger. And for today's demo or purpose, we'll use an IoT button. But you can use a trigger of your choice. You can also use Alexa, if you like, voice. So you can say, Alexa, I'm under attack, or Alexa, contact AWS DRT. So that trigger will then trigger Lambda code, which will create a case on your behalf, and then the case will come back to you if you're an AWS Shield standard customer. If you're an advanced customer, the case will be created, and also the AWS DRT team will also be notified, and DRT team will send you back an email with the Chime bridge, which is a conference bridge for you to join. So if we think about it end to end, your network or engineer or operator will click a button or a voice, and they'll get an email with Chime bridge, and they join immediately. So it's very, very fast. So we took that process and shrunk it down very, very short. So how does this work, or what do I do, or how do I sign up? So it's very simple. There are a couple of steps. You download the documentation from this URL here, and it's just a couple of pages, very, very short documentation. You follow the instructions to create an AWS Lambda function. And just to be clear, you're not writing the code for Lambda. It's already done for you. All you have to do is copy and paste the code. So you create the function in your account, and you copy paste the code. And then you configure a trigger. Again, it can be an IoT button, just like this one here that I have. Or it can be an Alexa, if you have an Alexa, or you can be any trigger you prefer. You will have to configure a couple of variables, very simple, and I'll show you. You do not need to be a developer to do that, very, very simple. And then lastly, you create an IAM role that allows your trigger to talk to Lambda. So let's talk about the configurable variables, or the configuring variables that you need to do. So if you are today a subscriber to AWS Support Enterprise, you change the security, the severity level from urgent to critical. And if you are subscribed to Shield Advanced, you change your support type from standard to advanced. And lastly, you change the test variable to on. Why would you do that? If you change it to on, what would happen is after you download your copy-paste your code, you do all the configurations you need to do, you press the button, then the ticket will be created and come back to you, but our support team will not take an action on it. The ticket will automatically close because we know it's coming from a customer that's testing. One important thing I'd like to highlight is once you conduct your test, you want to make sure you turn that back to off. Because if you keep it on, then the next time if something happens and you click, nobody will reach out to you. So make sure you test, and then you switch the variable to off, because now if you click, it's going to come as an actual request. It's urgent. Oops, sorry. So after you configure those variables, there's a couple more easy steps you can follow here, which are what I mentioned earlier, the predefined messaging. So there is a subject line, and there is a body. This only applies to Shield standard. If you are a Shield Advanced, you don't have to do this step. You can skip it. But if you're Shield Standard, this is a good place to modify your subject line to whatever you want to, right? Hey, we're under DOS, or here, this is our account number. Please reach out to us. And inside the body, I found that some of our customers find it helpful that they actually put their security team's phone number. So what happens there is when I click a button, AWS support gets the request and also gets the callback number. So then they know who to call. So a good thing to do is to add your security team's phone number there or whoever you want to be reached, and then you can get that contact quickly. And with that, I can show you a quick demonstration, which is not going to be as sophisticated as my colleague Jeff. But so I have a button here. It's pre-configured, right? And Lambda is ready. Everything is ready. All I do is I click it once, and then I should be able to get an email notification, either through my email and through the portal, and I can see the response with the ticket number. So HDMI. All right. This is my portal. It's called Support Center. Refresh. And this would be the response that I would get. Oops, sorry. So you can see the message that I would get from our support team. Thank you for contacting support. You will get a couple of questions, preliminary questions, right, to help the support team be prepared and ready. So is this a performance or availability, right? How can I test the reachability of applications? So if you can answer or just be prepared to answer these questions, again, we further reduce that time. So you're not on the phone starting from square zero. So you answer this or be prepared to answer these quick questions. And below you see the chime bridge. This is an example of a chime bridge that you will receive, and your team will just literally click and be on the phone with our DDoS team. And with that, I'd like to introduce Eric Neustetter, his VP of Technology at the POKÉMON Company International.
Thank you. And go. Oh, that's going the wrong way. There we go. So POKÉMON, what is POKÉMON doing at AWS reInvent? They're not a tech company. You might know us for our trading card game. There's billions of these little pieces of cardboard floating around the world. You might know us for our 20 seasons of animated series that you can find on TV. You might know us for video games on the Nintendo platform like Ultra Sun and Ultra Moon, which shipped about 2 weeks ago. The truth is, when nobody was looking, we became a technology company, and we've done a lot of that through the help of a partnership with AWS. This is the POKÉMON Trainers Club. The Trainers Club has been around for a number of years. It's hosted within Amazon Web Services, and you can go sign up on Pokemon.com and get access to a number of different Pokemon services. This is our worldwide auth service. We have many millions of accounts. Been around for a number of years, and it's served us quite well, although recently the usage of it has changed a little bit. One thing I do want to point out about the Trainers Club, we take the security of our child customers very seriously. If you go to sign up for the POKÉMON Trainers Club and you indicate that you're underage in whatever country you're located in, you're not going to be able to create an account. It's actually going to ask you for your parents' email. You put your parents' email in, it will contact them with information on how they can create an account and then set up and manage accounts for their children to use Pokemon. So once I have a Pokemon Trainers Club account, what can I do with it? There are a number of mini games on Pokemon.com. These are HTML5 games. They're free, they're fun, they feature cool Pokemon. Kids love them, and they're very simple and easy for small children to pick up. If you want to use the Pokemon Global Link, this is our worldwide service for games on the Nintendo DS platform like Ultra Sun and Ultra Moon, and you want to battle people elsewhere in the world, you need a Pokemon Trainers Club account to sign on to Global Link to do that. You can play the trading card game online. This is a digital representation of the physical card game. Same cards, same rules, allows you to play tournaments, practice, build up your digital deck just like you would in person. And finally, register for Play Pokemon events. These are our in-person tournaments. They might be at your neighborhood game store. You might be competing in a regional, international, or world championship event. This is how you register, how you keep track of your points and eligibility, and then move forward into those tournaments you have to qualify for. So everything was fine. The Pokemon Trainer Club was humming along, millions of customers, everyone was happy. And then Pokemon Go happened. So I'm guessing I don't have to go into Pokemon Go too much in depth. Most of you have probably at least downloaded it and tried it at some point. But I'm going to talk briefly about how it works, because that tells you why we needed something like AWS Shield Advanced. First of all, Pokemon Trainers Club was added to Go fairly late in the development cycle. Originally, the game was planned to be adults only. And then towards the end of the cycle, everyone realized, wait a minute, this game needs to be available to minors to play. Kids are going to want to play it. We want to give them a way to make that happen. So it got added in very late, without the opportunity for us to do a lot to really scale it up. And finally, Pokemon Go, a success beyond anyone's expectations. I actually joined Pokemon just after Go launched, but I've seen the various projections for how many people would play the game, and trust me, none of them were 750 million downloads in less than a year and a half. It's the most downloaded mobile game in history, and that's just not something you're going to anticipate. The way the game is supposed to work is you walk around with your phone out, and the GPS on your phone is reading data back from the game servers to find out what Pokemon are around you and where they are. It's using real Google Map data and then overlaying the Pokemon Go game data on that. So you walk around and you get hints that there may be a Pokemon here. For instance, if you look up on the screen in the top left corner, it's telling me that a Murkrow is nearby, and I can see what Pokestop it's nearby and go over to that Pokestop and track it down. So the idea is that's how you play the game. You walk around, you discover, maybe you go up a block to find the Pokemon you want and then realize, oh, it's over to the right, turn, walk another block and catch it. Not everyone likes to play games the way they're designed, and that leads to some of the problems that we've had. So Pokemon Go brought new challenges to the table. Number one, it was incredibly successful. It brought massive increases in both legitimate users and legitimate logon traffic to the Pokemon Trainers Club. It also brought to us massive disproportional numbers of illicit traffic. From bots, from scanners, and of course, our old friend, the DDoS attack. I'm going to go into bots and scanners briefly. I think we've already covered DDoS attacks, what they are. They're bad, high volume. If you run a service on the internet, you get to experience these. The bots, now, why would you run a bot on Pokemon Go? There's really two reasons. Number one, I want to look cool to my friends. I want to have a high-level account. I want to be able to show my friends my phone and say, look, I'm level 30. Look at all the Pokemon I've caught. I'm ahead of you. And some people just don't want to put the work in to make that happen. They want the shortcut. So maybe the way they want to do that is they want to use their favorite money service like PayPal and give someone a few bucks and buy their account off them and then show that as their own. So some people will take advantage of that. Some people don't want to buy an account, but they want to run a bot for themselves. And they want to take their existing account and level it up without having to do the actual work. So a bot's going to let you do that. And the state of the art of bots is pretty impressive these days. If you go look in the App Store on your phone, we're constantly trying to swat them, but you're going to find bots both free and paid in the App Store, whether we're talking Apple or the Google Play Store. So some people are out there spending money on stuff, and of course you download a free bot, who knows what's in there? Is it mining cryptocurrency? Is it stealing your username and password? You never know. Even more interesting, if you go to GitHub, you can download some pretty impressive source for bots. And not just this one, there's many of them out there. But they've gone to great effort to build very fancy bots that not only will do simple things like walk around and spin Pokestops, but allow you to configure specifically how it should behave. You can have rules around which Pokeball to use, which berry to use. Telegram integration. I want my bot to encrypted text message me when it does something. You can do that. You can even use Telegram to message your bot to tell it to do things. And there's Docker support in case you want to run your bots in containers. So this is a big problem for us. There are lots of bots out there. You can tell them apart from real people if they're doing things that a real person can't, like moving around at really high rates of speed. You were in San Francisco and suddenly you're in London 5 minutes later. That's probably not legitimate, those kind of things. Then there's scanners. So I showed you the basic map of Pokemon Go, and this is how you find Pokemon. Or you could use a scanner if you're the kind of person who wants to just flip to the back of the book and read the ending, and you don't really care about the 300 pages between the start of the book and the end of the book. What's a scanner? It's a map that shows me exactly where every Pokemon is around me. How do scanners get created? They build those maps by simulating thousands or tens of thousands of users, each of which are walking around. And by collating that data from lots of fake accounts playing the games at once, they can build a map and say, at this corner by the Starbucks, there is a Pikachu, and then people can go and get it without having to actually search for it. So obviously, against the terms of use, not a whole lot of fun. I question why people do this sometimes, but these are out there and there's something we have to fight against. So the world that we were in was we had a cloud-routed WAF, and we'd been doing business with that provider for a number of years, and prior to Go and all the extra traffic that it brought, that cloud-routed WAF did the job for us. We didn't need anything more. And then Go happened, and all of a sudden that was no longer sufficient. We just brought more traffic than they could handle as a company. The management interface would become completely unresponsive when under attack, so when we tried to either see what was going on or react to it, we wouldn't always be able to. Sometimes there would be so much traffic coming in, the WAF would just fall on the floor and stop passing traffic altogether, good and bad. So all of a sudden, no one playing Pokemon Go could log into the Trainers Club. And traffic was continuing to grow as Go got bigger and bigger, so we had to do something, and we had to do it fast. After evaluating our options, we decided the right thing for us to do was move to AWS Shield Advanced. This was made pretty easy for us because we already hosted the Trainers Club on AWS, but we had a really short deadline. The next big event that we knew was going to drive traffic was only 2 weeks away. And not only did we expect a lot of legitimate traffic from people taking part in the event, but events are what drive DDoS traffic. Whether it's an in-game event or it's maybe today is Christmas, people who do DDoS attacks love to find events to take advantage of and try to take you down. That's when they want to do it. So our DevOps team and InfoSec team, who are in the audience, thank you very much, folks. They worked really closely with the AWS Shield team, and in a week, we had started moving our traffic over. It started very small, 1% of traffic, 3%, 5% of traffic. We'd let it go for a period of time, examine the results, and slowly crank that up. It took less than 2 weeks from the day we made the decision to move to Shield Advanced to have all of our traffic for Pokemon Go Trainers Club login going through Shield Advanced. It's worked out really well for us. We have not had a single capacity issue with Shield Advanced. Not that I expected one because it's AWS, but it's been really nice. Our traffic has continued to flow no matter what has been thrown at us. A little surprisingly, our latency is actually significantly lower going through the AWS WAF than it was going through our cloud-routed WAF. We expected a little bit of improvement, but not really enough to be noticeable. It's been a really nice side benefit that we now have less latency for logins. and much better analytics and logging. We now have more visibility into what's going on when there is an attack and we want to deal with it, whether we're configuring the WAF ourselves or the AWS DDRT is doing it for us. There's a lot more data easily available to make those decisions possible. We've had a very close cooperation with AWS on this, with the roadmap for Shield. What features do we need? What features are coming to Shield? And we do use the IoT button. That's actually been super useful for us for a couple of reasons. Number one, it's just a shortcut. It shaves a couple of minutes off that response time of filling out a ticket, of making a phone call. You push the button, boom, there you go, the ticket exists. I also personally like it. I don't know how many people in this room used to carry a pager. I did. I love not carrying a pager anymore, but when you're rotating on-call individuals, there is something nice being able to say, and here's this, that helps kind of click into your head that, oh yeah, I'm on call now. I have to be aware and ready of this kind of stuff. In closing, bots and scammers are not going to go away. This is a fight we fight every day. We've got a team dedicated to the security of our systems and protecting our customers and making sure that whatever kind of attack is coming at us, we're noticing it and dealing with it. Shield has made our life much easier. It really has made a big difference for us. We were having real issues that real customers were noticing that are now gone thanks to Shield. The WAF is not a black box. As you saw in the demonstration, there's a lot of visibility into what's going on. That's super useful. Better latency and throughput, also super useful. Also, being able to just click this button and get help and have the people on the other end of that not only know what's going on and be familiar with our environment, but being able to make the changes for us. Maybe you're on call, but you're actually 15 minutes away from the house and your laptop. We don't have to wait the 15 minutes. We can just ask them to make the change in the WAF for us. Boom, protections in place for whatever new thing just popped up. And finally, our incident response process is a lot easier than it was, not only because we have one less vendor, but because we have a very clean process with Amazon. We're already working with them on other things. We know how to engage each other. We have each other's contact information. There's no worry that, oh, it's a holiday weekend. We don't know if we're going to be able to get a hold of somebody. That's it, with the exception of the team has some IoT buttons. So if you want to talk to them about getting a Shield button for yourself, I suggest you walk over. It's made our life a lot better, and there's actually a lot of other things we can do with it to make our life better through integration with things like Slack and PagerDuty. So I'd suggest brainstorming a little bit with those. You can probably help yourself out and make your life easier. Thanks for coming.